a force F is equal to K yi plus xj acts on a particle moving in xy plane. Starting from the origin, the particle is taken along the positive x direction to a point A0 and then parallel to y axis to a point AB. The total work done by the force on the particle is. The movement that is suggested by the question is, first, particle moves from here to here, point being A0, and from here to here, this point being AB. This distance is B, this distance is A. For the first time, when the particle was moving along x direction A to B, force on the particle that's been given as F is equal to K yi plus xj. Since y component of this force, it is actually 0, so from here to here the total force acting along the direction of the displacement is 0, so there is no work done in the first step. In the second step, the particle is moving from A0 to AB. This point or this axis is x is equal to A actually, so the force is acting along this direction only, and the value is F in y direction to be here, it is K into A. This is the force along the direction, and the displacement that's been given to be, that is B. So work done in the second case, it would be Ka into B. So overall work done by the force on the particle for the given situation is, work done total is KAB. Well, for the question number 11, looking into the options here, option 4 is the correct answer. In question number 12, the position and linear momentum of a particle at an instant r given as r is equal to 2I plus j minus 2k meter, and the momentum is I plus 2j minus 4k kg meter per second respectively. The angular momentum about the origin at that instant in kg meter per second, that's in SI unit. Well, straight away, angular momentum, how much it is? It happens to be r cross p. Simply we need to find out the cross product of the position vector and linear momentum. Well, we have been provided with position vector to be 2I plus j minus 2k, cross product with, it is I plus 2j minus 4k. Well, you must be knowing about the cyclic nature of this cross product, ijk, ijk. Well, L here, cross product of this portion will come out to be 0. Cross product of I cross j, it will be 4 here. I cross j will come out to be k here, and this is minus 8 2I minus 4k, and here I cross k will be minus j. So this is the cross product here. Second part, j cross I will be minus k, it will be minus k here, j cross j will be 0, minus 4, j cross k will be I. Next portion, this is minus 2 here, k cross I will be j, and this is minus 4 here, k cross j will be minus I. So angular momentum is this much. Just here it would be I, this will cancel out, j portion will be 6j, these two part, and here plus 3k. This is the value of the angular momentum. So option number 1 seems to be, in fact, option number 1 is the correct answer. So for question number 12, option 1 is the correct answer. Now let's take on to question number 13 here. In question number 13, the moment of inertia of a planar annular disk of mass m, inner radius r and outer radius 2r about its central axis is. The question here, it is this being the circular annular disk, inner radius being r, outer radius is 2r, total mass being m, so surface mass density will be m divided by 3 pi r square. Now we shall take small circular portion of width dr at a distance r. So mass of this much of the circular disk would be, it is 2 pi r dr. This is the area, sigma is the density, so this is the mass here. Its moment of inertia di will be 2 sigma pi mass into r square, r already there, so r square will be r cube dr. So overall answer will be given by the integration of this di from r is equal to capital R to 2r. Let's integrate it. So it is moment of inertia will be 2 sigma pi. This will be r4 divided by 4. This is 4. This is r4. Integration to be taken from r to 2r. Well, this is sigma pi divided by 2. This will be 2r to the power 4, 16r square minus r square. It is 15r square. Sigma was how much? It is m divided by 3 pi r square. So let's put the value of sigma, m divided by 3 pi r square. Remaining portion were pi by 2 into 15 r square. I am having the value of I to be this 3, it is 5 here. Pi will cancel out. 5 m r square divided by 2. 5 by 2 m r square. This is the final answer. Looking on to the options for question number 13, option 2, moment of inertia is 5 by 2 m r square is the correct answer. Now let's take on to question number 14 here. In question number 14, a billiard ball of mass m and radius r placed on a smooth surface when hit in a horizontal direction by a q at a height h above its center acquired an angular velocity omega naught. The linear velocity v naught acquired by the ball is, I would say, this being the uniform sphere considered to be the billiards ball. Moment of inertia about this axis would definitely be, I would write it down as 2 by 5 m r square if r is the radius, m is the mass. It's been hit at this point, this height is h, let the force being f. So I would suggest about this point the total angular impulse will be f dot dt into h, and what happened because of this force, it acquired the angular velocity omega naught. It must be equal to I omega. I is 2 by 5 m r square and angular velocity was, so clearly f dot dt, this will be the linear momentum. Fine, it is 2 by 5 m r square into omega naught divided by h. This is the linear impulse, so it must translate into the total linear momentum. So I would say it must be given as m into v naught, and from here m will cancel out. I'm having here with as 2 omega naught r square divided by 5h as the velocity the billiard ball will acquire once the cue will hit it. So looking into the option, clearly for question number 14, option 3 is the correct answer. Now let's take on to question number 15. A thin uniform rod AB of length L has linear mass density lambda x is equal to ax plus bl x square by L, where x is measured from A along AB. The distance of center of mass of a rod from end A is. We know the x center of mass has to be calculated as x dm integral divide by dm. So let's proceed the integral here. X center of mass, x dm being lambda into dx, it is ax plus bx square by L dx. This integration has to perform 0 to L, and again here it is dm, that means ax plus bx square by L dx 0 to L. So x center of mass is integral will be a x cube by 3, it is L cube by 3, plus bx cube, it is b, it will be L4 by 4L divided by a L square by 2 plus b L cube by 3L. So it is L cube, it will be 4a plus 3b divided by 12. Here in denominator it will be 3a plus 2b into L square into 6 here. This will leave us with 2 here, and this will leave us with L. So overall, final answer for X center of mass is 4A plus 3B into L divided by 3A plus 2B. Looking into the option for the question number 15, option A, center of mass is 4A plus 3B into L divided by 2 bracket 3A plus 2B. Option 1 is the correct answer. Now let's see the question number 16.